we want to talk about ionic theory and electrolysis. Ionic theory and electrolysis. We are just looking about introduction here before we discuss about electrolysis. One, we have to know things called conductors, poor conductors, insulators. Poor conductors and insulators. Before we discuss conductors, these are the material that allow electricity to pass through them. Whether solid or liquid or gas, if now they have capability to allow electricity to pass through them, we call them conductors. But insulators is an opposite to the word conductors. These do not allow electricity to pass through them. So, insulators do not allow, these are the material that do not allow electricity to pass through them. But conductors, these are the material that allows, they allow electricity to pass through them. So the difference between insulators and conductors is that insulators do not allow electricity to pass through them. But conductors allow electricity to pass through them. But poor conductors, somehow they allow, somehow they do not. So they lie between conductors and insulators. They lie between conductors and insulators. That are called the poor conductors. But now we are just talking about how we can differentiate conductors, insulators, and poor conductors. So these, they lie between the insulators and the conductors. If you do something to them, they may become insulators or they may become conductors. So they have got the capability of becoming insulators, and also they have got capability of becoming conductors. But if you do something to them, so this is not more discussed here. What we are discussing here is ionic theory and electrolysis. But we cannot have ionic theory with not knowing conductors and insulators. What is the intention of this one? Because we'll be talking about electricity passing through something. But the conduction of electricity is done, depends on the states of matter. If now you're talking about solid states, the conduction of electricity is only possible in the presence of electrons. In the solid states. If now you're talking about solids, the conduction of electricity is only possible in the presence of electrons. But if now you're talking about liquids and gases, liquid states, if now you're talking about liquid state and gaseous state, the conduction of electricity is only possible in presence of ions. And that is why we have ionic theory here. It is only possible if now you're talking about ions. Now the conduction of electricity in gaseous state and liquid state is only possible if in presence of ions. But in solid state, the conduction of electricity is only possible in the presence of electrons. If now this insulators have no electrons, conduction of electricity cannot happen. And therefore, from here, that is why we are just talking about ionic theory and electrolysis. So here, we are no longer discussing about electrons. I mean conduction of electricity in solid state. We'll be talking about conduction of electricity in liquid state. And that is why ionic theory and electrolysis. If now that is the case, let's talking about the liquids states. How do they conduct electricity? By using ions. So we are just talking about things which are in liquid form. They may be molten or they may be solution. And therefore, from here, we got something called electrolytes and non-electrolytes. So, electrolytes and non-electrolytes. Electrolytes and non-electrolytes. Electrolytes, we have said we are discussing about conduction of electricity in liquid state. Means they must liquid state. If now they want to conduct electricity, we have to talk about ions. If they cannot dissociate into ions, no conduction of electricity. So, the substance that dissociate into ions, they are called electrolytes. Now, electrolyte is the substance that, when they are in solid liquid state, that dissociates. Substances that dissociate into ions. Into ions when they are in molten states or liquids or solution to conduct electricity, to allow electricity to pass through them. Now, electrolytes, these are the substance that dissociate into ions when they are in molten state or solution to allow electricity to pass through them. If they cannot dissociate to form ions, they cannot conduct electricity. Example, if now you're talking about salt, that is solid. Salt does not conduct electricity. When it is in solid state. Solid what? State. Ile chumvi ukichukua ile chumvi ukaunganisha umeme kwenye chumvi, umeweka kwenye kopo. Ama umejaza chumvi ukaunganisha waya ukapita kwenye chumvi. Ukaukata katikati ukapita kwenye chumvi. Ile kavu balbu haiwezi kawaka. Kama balbu haiwezi kawaka, inaonesha kwamba no electricity conduction in the solid state of salt. Lakini ile chumvi ukiwekea maji ikawa uji, ina dissociate into ions. Ukiunganisha bulb inawaka, inaruhusu umeme ushike upite. In short, when salt is in solid state, if this is salt here, then you put the wire, you connect the wire, then here there is a source of electricity, let's say battery, and here there is a bulb. But here now you have not connected the conductors. The other conductor that you have pretended yourself is salt, but in solid state. The bulb won't light on, because these do not conduct electricity when in solid state. But once you add water into salt and becomes molten salt, this bulb will light on. Why? Because salt in solution, salt solution, or molten salt dissociate into ions to conduct electricity. Now, those substances that dissociate into ions to conduct electricity, they are called electrolytes. But those do not dissociate into ions. Now, non-electrolytes is an opposite of electrolytes. Now, non-electrolytes are the substances that do not dissociate into ions, and they do not allow current electricity to pass through them, whether they are in molten state. That is called non-electrolytes. Now, these do not dissociate into ions. That is all. Now, non-electrolytes are the substances that do not dissociate into ions when they are in molten state or solution. That is to say, they do not conduct electricity when they are in molten state. Now, the difference between electrolytes and non-electrolytes is that these dissociates into ions, but these do not dissociate into ions when they are in molten state. And that is to say, these do not conduct electricity, but these conduct electricity. Then, from there, we have strong electrolytes and weak electrolytes. We have to know strong electrolytes and weak electrolytes. Strong electrolytes, these dissociate completely. This dissociates electrolytes, dissociate completely into ions when they are in molten state. They are in molten state or solution. But this also, they dissociate partially. They dissociate partially into ions when they are in molten state. So, in other words, we just have weak electrolytes, and strong electrolytes. Strong electrolytes dissociate completely into ions when they are in molten states or solution. So, this is the pure conductor of electricity when they are in molten state. But this is the weak conductor of electricity when they are in molten state. So from here we have weak electrolytes, they dissociate partially. So it is where now you find the poor conductor of electricity when they are in molten state. Because they dissociate partially, not completely. Now that is the difference between strong electrolytes and weak electrolytes. This is dissociate partially, but this dissociate completely when they are in molten state. Now this is a good conductor of electricity when they are in molten state. And it is from there, by knowing what is electrolytes and what are the non-electrolytes, it is from there now you can define what is electrolysis. Therefore, definition. After we have known what is electrolytes, now electrolysis is the process in which an electric current through an electrolytes causing chemical reaction. Now it is from here now we can define the word electrolysis. Now electrolysis is the process in which an electric current is passed through an electrolyte. Means this electric current passed through an electrolyte, substance that dissociate into ions, allowing electricity to pass through them, causing a chemical reaction. Once electric current passes into the electrolytes, they cause a chemical reaction. Because they are already there ions that allows electricity to pass through them. And the place where this electrolysis is conducted, we call it electrolytic cell. Electrolytic cell. Now, this is where now electrolysis is conducted. We say electrolytic cell apparatus. This is the apparatus in which the electrolysis is conducted. Electrolysis is conducted. So the apparatus that we use to conduct electrolysis, we call it electrolytic cell. But electrolysis is the process in which an electric current pass through an electrolyte, causing chemical reactions. And the electrolytes, I've said, are the substances that dissociate into ions to allow electricity to pass through them. Electrolysis ni pale umeme unapopita kwenye kitu kinachoitwa an electrolyte. Na electrolytes ni zile ambazo zina dissociate into ions zikiwa katika molten state au solution state, ili kuweza kuruhusu sasa umeme uweze kupita. Nimekupa mfano, chumvi ikiwa kavu haipitishi umeme, lakini ukiloanisha ile chumvi ikawa uji au ikawa solution inapitisha umeme, kwa sababu chumvi ina dissociate into ions. That is sodium chloride. Now sodium chloride is a common salt. Once it dissociates into ions, we form sodium ion and also we form chlorine ion. Once they dissociate into ions, they allow electricity to pass through them. So that is how now we can know how to define electrolysis as an introduction. Electrolysis is the process in which an electric current is passed through an electrolyte, causing a chemical reaction. But the apparatus that is where the electrolysis is conducted, we call it electrolytic. Electrolytic, not electric cell. electrolytic cell. Electrolytic cell. Now, electrolytic cell is the apparatus in which the electrolysis is conducted. That is called electrolytic cell. So we will see the terminals and the parts of electrolytic cell, which are electrodes and anodes. Which are electrodes. And the electrodes are the cathode and anodes. What are the cathodes? What are the anodes? Not the anode, your friend. So we have anodes. So we will be talking about electrodes. Electrodes. These are the components of the electrolytic cell. Now, electrodes, we have anode and we have cathode. So we have anode and cathode. So these are the components. Electrodes are the components of electrolytic cell. And one of them is positive and one of them is negative. And we don't say negative and positive. No. One of them is connected to the negative terminal of the battery. And one of them is connected to the positive terminal of the battery. So this is all about introduction of ionic theory and electrolysis. So when talking about ionic theory and electrolysis, we'll be discussing about this one. And it is where now we are going to talk about Faraday's law. Faraday's laws of electrolysis. We have first Faraday's law and we have second Faraday's law. And it is a very important thing to discuss about this. Now for today, let us end up here.